We have seen that it can be very useful to have a class inherit from several other classes. This is known as multiple inheritance. But as soon as we have multiple inheritance, we have a small technical problem that we have to address, the problem of name clashes. Assume a class C, which inherits from a class A and a class B, and both of these classes have a feature with the same name, F. What does it mean for C? How does it resolve the conflict, the name clash? The solution is actually at the language level very simple. To understand it, it's going to be essential to remember that a class should be a mapping between feature names and features. That's what the class defines, a mapping between some names, for example, F, G, and H on the left side, and some features, some code, some actual functionality represented here on the right side. And this correspondence between feature names and features should be a function, also known as a mapping, meaning that for a given name such as G, here there should be just one feature, one piece of functionality, one piece of code that corresponds to that name. Now, those of you who have used other object-oriented languages than IFL know that this rule is not always applied. In some languages, there's a notion of overloading, which makes it possible within a class to have the same name for different features, but this is a really bad idea because it only introduces confusion and doesn't really bring any new possibility. So we are going to work in a context without any overloading, meaning that this correspondence between feature names and features is really a mapping. And so if we apply this principle, then the solution is going to be quite simple. Because if we just let C inherit from A and B with, in both cases, a feature called F, we would have two features with that name in C, and that is not permitted because it violates that principle. And so to understand how to address this issue, we also have to realize that it cannot be a very difficult problem because it's only a matter of a name clash, but kind of a pun, if you like. It happens that we have two features with the same name, but these are two different features. The feature called F in B and the feature called F in A. They just happen to have the same name. So it's not a deep problem. It's a simple problem, and it's resolved by a simple solution, which simply consists of changing the name at the point of inheritance. So that's exactly what we're going to do here. For example, if we want to remove the clash, we can, when we inherit from A in class C, rename F as, for example, A underscore F. Of course, we can use any name we like. Here I'm using A underscore F to emphasize that the feature comes from A, where it was called F, but any convenient name would do. Now, this clause, rename F as A underscore F, is a clause that is going to be part of the inheritance clause of C. We're not going to touch A, and for that matter, we're also not going to touch B. Anything at the top here will remain unchanged. Of course, we're not going to change a class just because we're inheriting from it. This would be a violation of the very idea of inheritance. But when we inherit from a class, we have the freedom, as in the case of C, to adapt what we inherit to the local context of C. So in a situation like this, before we actually see the detailed class text, let me just make sure that everything is completely clear. What's permitted, what's not permitted. So we're going to have A1, B1, and C1 of respective types A, B, and C. The names are mnemonic for these variables, so we can certainly do C1.F. In that case, of course, this means the F from B, because F in C means only one thing. In general, a name can mean only one thing. The feature that is inherited under the name F in C is the feature that comes from B. C1.AF is also possible, and of course it means in C the feature that comes from A. A1.F, no problem. B1.F, these are all possible. On the other hand, if we try something like A1.A underscore F, well, there's no feature called A underscore F in class A, and A1 is of type A. So that would be rejected by the compiler. The rule here is very simple, is that x dot something is only permitted if something is the name of a feature in the static type, that is to say the name of the class with which X is declared. And so here that is not the case. A1 is declared of type A, and class A does not have a feature called A underscore F. And in the same way, B1.A underscore F is also not permitted because there is no such feature in class B1, and that's the message that you're going to get from the compiler. Are all name clashes bad? Not absolutely. There are going to be two cases in which we can accept a name clash. The first one is under repeated inheritance. So we're going to see repeated inheritance next. And repeated inheritance in this case simply means that we don't have a real name clash. That is to say, the feature that is inherited by C from both B and A seems to be different, but in fact, in both cases, it comes from a common ancestor, say D. So in that case, known as repeated inheritance, we don't really have a clash, and it's okay. Another case in which a name clash is permitted is when we have, again, C inherit from both A and B with a feature called F in both cases, but in one of them, or maybe both, F is actually deferred. The most interesting case is one in which F is deferred on one side, like A here, and is effective, not deferred, on the other side. So what it's going to mean in this case is that we use the implementation from B to serve, to effect, to implement the deferred features inherited from A, and that is not an error, it's a normal case. So we'll see this in more detail in the next segment or two, but coming back to the general rule, let's compare renaming and redefinition, because we have seen that there is renaming, but before that we had seen the mechanism of redefinition. It's interesting to see that these have complementary roles. For an inherited feature, you can redefine it, meaning that you change the feature, but you don't change the name. Remember this mapping, the mapping between names and features. Well, in that mapping, redefinition changes the stuff on the right. Remember, we had this little picture which said F is associated with a certain piece of code, G is associated with another piece of code, and H with yet another piece of code. So when we redefine the feature, we change the code. We change the actual operation associated with F. And we don't change the name, of course. When we do renaming, well, it's the reverse. We're going to rename F as something else, and this is going to change the feature name and not change the feature. So it's quite simple and straightforward. Of course, if we want to, we can combine these two mechanisms. So we could, for example, have rename F as G, redefine G, meaning first change the name of F, and then with the resulting feature, redefine it, provide a new effecting, a new implementation of it. That is perfectly possible. By the way, these inherit clauses can have rename, redefine subclauses. In this example, illustrates the syntax. It starts with rename if present, rename always has an as, and then it continues with redefine if needed, with a list of features, and then it always ends with end. That's the way it looks like. Here's another application of renaming. I've introduced renaming as a mechanism to remove name clashes, but it also means that when a class inherits from another class and gets some features from it, it keeps these features unless it redefines them, but it doesn't have to keep their names. So sometimes it can be better to adapt the name to the local context of the new class if the original name was not adapted. Maybe the original feature is okay, but the original name is not ideal for the new context. Assume, for example, that we have a hierarchical window system in which windows can be nested into other windows, and then each window can have some windows, we can have some windows, and so on. So one way to represent this notion is to make window inherit from tree. This is a bit similar to the structure that we had with composite figures. And so window will inherit from a tree. However, in the class tree, we are going to have terminology which is adapted for the tree view of things. Things like parent, children, add a child, remove a child, and so on. Now, for class window, these features are completely appropriate. We actually are going to need all these mechanisms, but maybe the terminology, maybe the names are not quite ideal. Instead of parent of a window, we might want to talk about the super window of a window. Instead of the children, we might want to talk of the sub-windows, and so on. So renaming gives us that flexibility. We can inherit functionality that we like, but we don't have to keep the names if we don't like them, if we find they're not appropriate to our new context. Now, I should add here that the recommended style in object-oriented development, in particular in library development, is to use pretty standard names. You will have noted, for example, in looking at Eiffel libraries, that you have lots of classes with features having names such as item, put, remove, count, and so on. These are standard names, and they are recommended. So we don't abuse, we don't use too much these mechanisms of adapting names to local context, but sometimes they can be very useful, as illustrated by this example of the tree terminology being adapted here to Windows terminology. So what we've seen in this segment is that it is very important to distinguish between features and feature names, and we have seen a mapping between the two. We've seen that a class establishes a correspondence between names and features. For every name, there should be at most one feature in the class, no overloading. And we've seen a very simple mechanism, the mechanism of renaming, which solves the name clash problem, and which, in addition, can be used to fine-tune the names of inherited features to the exact context of every particular class.